Hey, what's up? I'm Dave Boyer, aka Mr. Boyer, aka the Swamp Man. I'm here in my classroom in Kernersville Middle School, and I'm about to teach a lesson about divergent plate boundaries. So I'm going to walk over here to the whiteboard and we'll take a look at our lesson objectives. So here's our objectives. Our first objective is to understand what action is involved in divergent plate boundaries. We're then going to move on to what's the cause of that action, and then we're going to finish with what's the result from that action. So we're going to take a page of notes in our science notebook. This is how we're going to get it set up. This is where your next page that you have available. You need a title at the top. We're going to title this page Divergent. We're then going to draw a line to separate our page into a top third and a bottom 2/3. So you're skipping down maybe 6 or 7 lines or so below your title and drawing your line straight across. So that's how we're setting up our page. I'm going to go ahead and take that off the screen so that I've got a little bit more room. And the next section we're going to fill in is this top third of our paper. So again, we need a title at the top. And we're going through divergent plate boundaries. So I've been kind of trying to teach this, these plate boundaries using the prefixes from each of the words. So we had convergent plate boundaries. Prefix con means comes together. And divergent plate boundaries means apart. So you can already kind of hopefully envision what is going to happen as the action if we have apart as our prefix with our plate boundary. But just to kind of make a connection to a couple of other words that use the same prefix of die, one of the most common in school is the prefix divide, a math operation. But you can also divide items up. So like I've got a piece of a candy bar here. If I were to divide it among 2 people, I could get a bite by taking it apart from it and share the other bite with my friend. As I'm chewing up this and making a fool on camera, another word that uses the prefix die is digest. So as I swallow that piece of candy bar, it's going to go through my digestive system, and the digestive system is going to rip that apart and break it down into smaller and smaller pieces so that it can be absorbed into the bloodstream and carried around my body. So die means apart, and that's going to help us see the action that's involved. So we're all still in this top third section, and the next thing to talk about is that action. So with a prefix like die meaning apart, the action is going to be that our 2 plates, because any 2 plate boundaries out of plate boundary are moving, and in divergent, those 2 plates are moving apart from each other. So we've got 1 plate moving to the left, 1 plate moving to the right, and in the middle between them, the plates are being pulled apart from each other. So that's the main concept in a divergent plate boundaries. Our plates are moving apart from each other. Next, we're going to take a look at the cause. For any of these plate boundaries, the cause is going to be what's happening underneath those plates. So we've got our layers of the earth. We're going to have the crust up here that we were just talking about. We have the mantle that's down below that, which I'll come back to in just a minute. And then down at the very bottom, we have the core. Some of the main concepts about the core that we've already talked about are going to be that the core is exceptionally hot. The inner core can get as hot as 10,000 degrees Celsius, as hot as the surface of the sun. But it's not evenly spread out in its temperature. So there are some areas of the core that are going to be just hot and other areas that are going to be hotter. So I've drawn a hotter section in the middle here of the drawing, and then a little bit cooler, still labeled as hot, around the outsides of that. And we're looking at the mantle. So this brings us back to, and we've talked about it several times now, the convection currents that are happening in the mantle. We'll try to go kind of quickly through that just to draw the cause of the movement of these plates being pulled apart in the divergent plate boundary. So the hottest areas of the core are going to heat up this liquid magma, this liquid rock inside of the mantle, and cause it to become less dense and rise towards the top of the mantle. Well, as it rises and we get more and more rock building up here, that's going to increase the pressure in this area, and fluids must go from high pressure to lower pressure. If we've got high pressure in the middle here, that is going to cause the rock to spread apart along the top of the mantle. As it's spreading apart, it's going to also begin to cool down. As it cools down, it's going to become more dense and sink down towards the bottom of the mantle, increasing the pressure where it's sinking, and it's going to fill in and replace the magma that was leaving above that hotter area, thus completing our convection currents. So if we have two convection currents that are drawn here side by side with this upwelling of magma coming up and through the center of it, and then we look at the top of the mantle, we've got our arrows pointing in opposite directions. The crust sitting on top of that floats on that, and it goes with the flow. So this plate is going to move to the right, this plate is going to move to the left, thus apart. Divergent plate boundaries. So there we've got the action and the cause. Let's take a look at some of the places around the Earth that we could see this. So I'm going to switch over to a map of the plates. And we're going to look at two different areas for this divergent plate boundaries. One of the areas that we're going to look at is this dark black line that runs through the middle of the Atlantic Ocean. All these black lines are plate boundaries, areas where two or more plates come together or meet. And in between the Eurasian plate here on the top right of the screen and the North American plate in the middle of the Atlantic Ocean, we have a divergent plate boundary. The North American plate is shifting to the west. The Eurasian plate is shifting to the east. They're pulling apart from each other, and we'll see what that does in just a minute. Another place that we're going to look at in just a minute is around the eastern side of Africa. So we've got two areas here where we can look at divergent plate boundaries. One that happened a while ago was between the African plate and the Arabian plate. And then there's a new one that's been happening for a while actually also, but it's still currently active, is the African plate is splitting into some smaller plates. And we're going to look at those in just a minute. So let's go back to our notes paper. This was the top third of our notes. I'm going to take this off the screen so that we can work on that bigger section, the bottom 2/3. So down the bottom 2/3, over on the left-hand side, we're going to kind of keep consistent with how I'm setting up all these notes. We're going to write down the result. And then at the top, we're going to have a statement about the result. And our statement is going to be that the result depends on the type of plates involved. So we have two main types of plates: continental plates that are holding up continents and oceanic plates that are holding up oceans. So essentially we can kind of look at different areas of divergent plate boundaries as things that happen on land versus things that happen in the oceans. And that's what I'm going to kind of set this up as. So we can now divide our paper into a left side and a right side by drawing a line straight down. On one side, we're going to look at that Eurasian and North American plate, and on the other side, we're going to look at what's happening with the African plate. So let's go ahead and label our example. So we're going to have the North American plate coming apart from the Eurasian plate. And again, this is happening throughout the middle of the Atlantic Ocean. And that line actually continues down into the southern hemisphere, and the same boundary could be true between the South American plate and the African plate down in the southern hemisphere. But we're going to need some plates involved. So here's the result. We've got our two plates that are next to each other. We have our action. Action is that the plates are being pulled apart by the convection currents in the mantle that are underneath those. And as these two plates move apart from each other, sorry, we're going to do a little arrow here to go down. As these two plates move apart from each other, keep in mind what's underneath them. We've got magma, we've got liquid rock down in the mantle. And that liquid rock is it's always trying to find a way to relieve pressure. And as the plates pull apart from each other, they open up a fissure, a crack in the Earth's crust. Down below that, the magma is going to start to seep up through that crack. Now this makes it seem like we're going to have this really explosive volcano, but we're in the bottom of the middle of the Atlantic Ocean, and we're not building up volcanoes there. There is magma coming up, so we can kind of consider that to be a volcano, but it's going to have a pretty different effect than the volcanoes that we would typically think of. So this magma, as it rises up through this crack in the crust and it spills over on top of these plates, the North American plate and the Eurasian plate, it's on the bottom of a really cold ocean. And that liquid rock isn't going to be able to stay liquid, and it's going to turn into solid rock. And so, it's too close. Over time, it's going to have piles of hardened rock that form on top of those plates. And at the same time, we're constantly having new rock coming up and spilling through the crack between those two plates. And so each little movement, each new rock that comes up and cools down and hardens into solid rock is going to create these bumps on the bottom of the ocean called ocean ridges. So the real effect of this is going to be that we have an ocean floor in the middle of the Atlantic that's going to have all these different ridges. So we got ocean ridges. The one in the middle of the Atlantic is called the Mid-Atlantic Ocean Ridge. And we actually discovered this, and during World War II, we started sending boats that were using a new technology called sonar, sending sound waves down to the bottom of the ocean and mapping out the oceans while searching for German submarines. And later, when we went back to explore them with scientists, what they found was that equal distances away from this trench where the lava is coming up, equal distance away were rocks that were the same age. We can date rocks that come up from the mantle and cool and harden. So, we might have rocks on this ridge that are, say, 1,000 years old, and rocks on a ridge that is the same distance away from the upwelling of magma is also 1,000 years old. And the rocks further away are going to be even older, but they're going to match rocks that are the equal distance apart from the other one. So the bottom of the Atlantic Ocean has all of these ocean ridges. I'm going to switch to looking at a picture of that. So this picture is not necessarily to scale, but we can see here we got South America, North America, Europe, and Africa. And all the way from the Arctic down through the middle of the Atlantic Ocean and all the way down to the Antarctica are all of these ocean ridges, all of these bumps along the ocean floor where new magma is coming up from down below. if you can see the line that's running through there, that's the actual plate boundary between up here, the North American plate, and the Eurasian plate that's there. If we were to consider this to be a mountain range, because it basically is, it's just underneath the ocean, this would be the longest mountain range on planet Earth. So let's take a look at another example of a divergent plate boundary. We had here the North American plate and the Eurasian plate being pulled apart. This is in the middle of the ocean. But if we have that on land, like for example, between the African Nubian plate being pulled apart from the African Somali plate, so those are really two pieces of the African plate that are breaking apart from each other. So in the future, we can't really consider the African plate to be one plate. It's going to break into smaller plates over time, and it has been for a while. In fact, if we go back to looking at some pictures really quick before we get into drawing what's happening with the African Nubian and the African Somali plate, I'm sorry, I need to be back over there.